Hello and welcome to this video lesson. So this lesson is about empirical formulas. So the goal for this lesson is that by the end you'll be able to determine the empirical formula of a compound using percent composition. Okay, so just to review, molecular formulas we have been working with throughout this course. So molecular formula is basically the exact number of atoms of each element within a compound. So for instance, the molecular formula for water is H2O. The molecular formula for hydrogen peroxide is H2O2. These represent the actual formula for these molecules. So it's telling us the exact number of atoms of each element within the compound. So here is the definition for molecular formula. This might be something that you want to write in your notes that go along with this video lesson. So using our same molecules, so H2O and H2O2, so water and hydrogen peroxide, the empirical formula is the simplest whole number ratio of the elements in the compound or molecule. So for water, the simplest whole number ratio would still be the same. Our empirical and molecular formulas are going to be the same. But if we take a look at hydrogen peroxide, we have 2 hydrogen atoms and 2 oxygen atoms. So if we get the simplest whole number ratio, what is a common factor that goes into each of these numbers? Well, it's 2. So our empirical formula for hydrogen peroxide would be HO. So for water and hydrogen peroxide, we're comparing our molecular and empirical formula. Molecular formula is the actual formula, so the exact number of atoms in each element within the compound. Your empirical formula is your simplest whole number ratio. In some instances, the molecular and the empirical formula are going to be the exact same, but in some instances, they're not. Now here's our definition for empirical formula. Again, you might want to add this to your notes that go with this video lesson. So the best way to identify an unknown compound is to determine its chemical formula. So how do we do that? Say chemists have an unknown compound. Well, they would maybe put it through that combustion analysis apparatus, and then they would get the percent composition. From the percent composition, we can then calculate what the empirical formula is and eventually the molecular formula, which will then identify the compound and then we will know its properties. So let's try practice number 1 on page 292. In this question, it is telling us the percent composition of the elements that make up that compound. So let's pretend it's unknown, it's been put through this combustion analysis apparatus, and we get the percentages that are listed on page 292 for question number 1A, practice. So 20.2% is aluminum, and 79.8% is chlorine. So for this particular problem, again, let's write our givens. The percentage of aluminum is 20.2%, the percentage of chlorine is 79.8%. What we're looking for here is the empirical formula. Now, for empirical formula, we're going to just write a general equation to represent this, and then we'll fill it in with the actual numbers. So we're dealing with Al, and we're just going to say X to represent the subscript that would go with aluminum, and then chlorine, and we're going to use the subscript Y to represent the number that goes with chlorine. Okay, so we're going to start to solve this. So our analysis and the solving component we're going to put together. So our givens were given as percentages, but we need to work with mass. So what we're going to do is change those percentages into mass. So again, these are given as percentages. We're going to assume that if we're dealing with 100%, let's say that we're dealing with an 100-gram sample. If we're dealing with a 100-gram sample, 20.2% is aluminum, so that would mean 20.2 grams is aluminum. 79.8% is chlorine. So again, if we're dealing with a 100-gram sample, 79.8 grams would be chlorine. So we're going to write this down as part of our solution. So here is our mass of the elements that make up this compound. Another piece of information is big M, the molar mass. We always seem to need that. So let's get the molar mass for each of these elements. So molar mass for aluminum is 26.98 grams per mole. The molar mass for chlorine is 35.45 grams per mole. So our first step is going to be to find the amount of each element involved in this compound. So we're going to find the amount, the N for aluminum, and the N for Cl. Amount again refers to moles. So let's use our N equals little m over big M. And here's our equation, and now let's fill it in. Okay, so our N for aluminum, we're going to use the mass that we were given. Well, we were given a percentage, we converted it to mass, and the molar mass. For our N for Cl, we're going to use the mass that we were given, that we converted from percentage, and we're going to divide it by the molar mass of our chlorine. Okay, get your calculators out and find the answers. So the moles for aluminum is 0.74870, grams cancel out, and our answer is in moles. Now we're going to need 3 significant digits in our final answer, so we're tagging on 2 extra digits until we get to the end. Now find the moles of chlorine. Okay, so I got 2.2511 moles for the moles of chlorine, and again grams cancels out, leaving our answer in moles. Okay, so our next step is we're going to look at these 2 moles and we're going to figure out which one is the smallest number. Right, our moles of aluminum is the smallest number. So what we're going to do is divide each of these amounts by the smallest mole amount. Okay, so that's our step 2. We're going to divide the amount of each element by the smallest amount. Remember, amount is moles. So we're going to divide by 0.74870 moles. And we're going to divide each one, or however many elements are involved in that compound, by the smallest amount. Okay, get your calculators out and solve them. Okay, so dividing the amount of aluminum by the amount of aluminum, we get 1. Okay, now what this is going to represent is the subscript in our empirical formula. Now we're going to do the same for chlorine. Divide 2.2511 moles by the amount of aluminum. Our moles cancels out for everything, so all we get left is with a whole number. So in this case, we get a 3. Now in instances where it isn't a whole number, you're going to have to multiply it until it is a whole number, and then apply that factor to all the elements that are involved in making that compound. Okay, but back to this example. So in this case, we have a 1 to 3. So what this represents is the formula. So in this case, our formula is going to be Al1, but we don't write ones, Cl3. Now just so you can see the different steps that are involved in solving this type of problem, step 3 again is the calculations, and step 2, give the empirical formula. So our answer is AlCl3. And the last part is we need a statement. So therefore, the empirical formula is AlCl3. So I would like you to read section 6.7, and as well I would like you to try practice question 1D on page 292. Use the example that was used in this video lesson as well. You might want to check your textbook. because the examples in your textbook are well done. Now remember, when you go through these video lessons, you should be writing notes. And that marks the end of this video lesson.
Made with Doodlecast Pro.